So let's just think about what is the distance where an echo is distinct from a reverberation. Since we know that the speed of sound in air is this 340 meters, how far away will an object have to be, or will a surface have to be, for it to form an echo rather than a reverberation? Hongyi, what do you think? Is the velocity constant? Yeah. So the speed of sound in air, we say it's constant at always 340 meters per second. Okay, I see what you're trying to do. You're trying to use like the kinematic equations. So those are for regions of constant acceleration, things like cars or like objects, right? So they have like a constrained use. So we can apply them here, but we don't really need to because the wave isn't accelerating. It's just traveling at a constant speed. So we don't need to worry about that. The only thing we need to worry about is that velocity is distance over time. Oh, sorry, displacement over time. So displacement is velocity times time. Okay, you said 340 times 0.1. Okay, that's a good guess. But let's think about what happens. I see where you're heading with this. Let's put a speaker here. I don't know how to draw a speaker, but something like that. And let's put the person here. And we have a wall here, a reflective wall. So the speaker plays a note and the person is like right next to it. So they hear it instantly when it's played. And then the note or the sound waves travel all the way to the wall and they travel all the way to the person, right? And they travel at this constant speed of 340 meters per second. So we know that the time that the sound is traveling for it to be an echo, it has to be greater than 0.1 seconds. Let's call this distance d. So the time has to be greater than 0.1 seconds. So the sound is traveling all the way to the wall. That's a distance of d. And then all the way back to the person. That's another distance of d. So in total, it's traveling 2d. Does that make sense? Because it's traveling to the wall and then back to the person. So if the displacement is 2d and the velocity is 340, the time is 0.1. Let's solve for d. So 2d is 340 times 0.1. D will be 17 meters. I'm not going to do greater than or plus 1. Let's just ignore that for now. So 17 meters, that's like 2 buses next to each other, maybe 1.5 buses in a row. I don't know how big a bus is. It's like 4 to 5 cars in a row is 17 meters. Just as an estimate for how far away it needs to be. Okay, so just as a quick aside, what I was saying about bathrooms, right? So if you've like been in an echoey bathroom, you'll know if you play like if you like clap in an echoey bathroom, clearly it's not going to be 17 meters away, right? It might be only 3 meters to the wall maximum, unless you're in a really huge bathroom, in which case, yeah, good for you. You have a nice bathroom. But if you're a typical person with an average size bathroom, it's not going to be 17 meters across. It might only be like 3 meters across or something. So what will actually happen is the sound will travel back and forth between the bathroom walls so many times because the walls are just reflective. So they absorb very little of the sound. And they'll travel so many times back and forth that eventually they'll travel for more than 0.1 seconds. And then we'll hear them. And that's when we'll notice an echo. Even though the actual distance they're traveling, one path length is not very big. It's only maybe 3 meters. We'll still hear an echo. And that's why we don't hear it if we have like furniture. Because if we have like a sofa here, that's a sofa, this will like absorb the sound. So it won't be able to travel like 5 times through the sofa because it'll just absorb all that sound. So yeah, that's just why some rooms are echoey and some rooms aren't. Does that make sense? Anyone have any questions about reverberations and echoes or how we found that it was 17 meters? Hopefully that made sense, Hongyi.